So have we talked about and or yet? All right. So, thing to remember is that and can usually replace nested if statements, right? If number calls greater than 0, if minutes used greater than 0, do something. Or you do it like this: if number of calls greater than 0 and minutes used is greater than 0, then go do this. Now there may be some particular reason that you don't want to use an and, that you really want to use nested ifs. And that's if you want to have multiple outcomes, more than just a true-false. Because if you look, this could support 3 options, right? If the outermost question, if calls greater than 0, if calls greater than 0, do something else, print a message, okay. Well, we didn't need to do anything else other than print that message if this was not true. But what if we go in here? There may be 2 options we want to do if our calls were greater than 0. All calls were international as opposed to some calls were domestic, right? We might need to print 2 messages. So there we have 3 different options that we would not have been able to do if it had just been an and chained together, because then you'd only have 2 options. So when you're nesting your decisions, either selection can come first, but you want to ask your questions in the correct order. And when they say ask the questions in the correct order, you can actually improve the performance machine language-wise, but in general they mean something like this. That's more technical. This is more general. I believe we're on P. Yep. All righty. Like this. If you are Hispanic and you are under the age, okay, let's do this. Input X equals Hispanic, X equals input Hispanic, yes, no. And so you do if X equals Y, or yes, right? Something like that. This is not good Python code, or it may wind up being good Python code just because I can't help myself. And then we ask them another question. If they are Hispanic, we're going to say, do you speak the English language? Or do you have, yeah, let's do that. So Y, Z is equal to input. How about are you native born? And I'm not really trying to get all Trumpian here. I was just trying to get some questions going here. All right. And then if that's true, we're going to do something else. So if Z, we're going to print something. I don't care what. Now say that you live in an area that is 4% Hispanic and 90% of them are native born. Well, do you want to ask this first, or do you want to ask this question first? Because we could swap the order, right? But if only 5% of the folk are Hispanic, what if we were asking, are you native born first? Well, 95% of the time, you're going to have to go ahead and go in and do this question. So, if 5% Hispanic, and of the general population here, if 95% are native born, Hispanic or non-Hispanic, then the order in which we ask these dictates whether we ask one or two questions. So if we always ask if they're native born first, then 95% of the time we have to ask the second question. The user has to type in two things. But if we put the first question first, only 5% of the time will people have to enter two questions. That's a performance enhancement just for the people typing it in. And also, if this was expressed as an AND statement, if you had two conditions, if x equals y and z is equal to y, then it actually gets compiled and optimized so that only the first check is made and not the second check. So doing one more. You know, if we have money and we are hungry, then do something. Each check, each comparison requires some computing cycles to process. Now nowadays computers are amazingly fast, but still if you're writing graphics drivers for video games and stuff like that, you want them to be as fast as possible. And Python doesn't run really very fast, so this kind of performance enhancement doesn't matter as much as this kind of thing where we want to control which question gets asked first, and you want the question that can rule out. You want the one that is least true to be first, so that you can rule out 95% of the time when the second question is going to get asked. Similarly, say we only have money 10% of our life, but we're hungry 90% of our life. I guess we're like Shaggy on Scooby-Doo or something like that. We're almost always hungry. If this check is true, if we have money, since this is and, both sides have to be true, right? So, if this is true, it has to come over here and check this one out as well. It has to do two comparisons. Take twice as much time in the computer. If this one is false, does the computer even need to check to see if we're hungry? Absolutely not. Because if this is false and AND requires both sides to be true, then the computer doesn't even bother to check the second half of the AND. So you want to put the one that is least common in front to rule out so that only one comparison has to be done more than often. And so we said that we rarely have money, but we're always hungry. Well, then we put that check first so that it can rule this one out as often as possible. Now, OR is the opposite. Let's just write that as a general rule. Put the question that is true least often in front, or first, either in a nested if or when using AND. I hate even throwing the word in or, right, because we're talking about ANDs. Either with nested if and syntax. The opposite's true of or. In or, you want to rule out the one that is least true. Why is that? What if we are sick or tired and we get to stay home? If sick or tired, stay home. What if we're sick only 1% of the time? We have reasonably good health. However, we're tired 90% of the time. If we are in fact sick, does the computer even have to check the second clause? Right? No, because we get to stay home just because we're sick. Only one side of the or has to be true. So if we are sick, we don't even need to ask if we're tired. But we are only sick 1% of the time. So 99% of the time, it's going to go ahead and have to check to see if we're tired anyways. Right? So the vast majority of time, it's got to do two comparisons. Or if we structured it as dual if nested if statements, it would have to ask two questions 99% of the time. And if we swapped them, right? If we made it if we are tired or sick, well, 99% of the time, we don't even have to check the second thing because the first part is true, right? Knowing that we're tired is enough. Our boss sure is nice. We get to stay home whenever we're tired, 99% of the time. Wow, that's a wild job. Anyways, you get the idea, right? If only one of these has to be true, if the first one's true, the second check can get skipped. You arrange them in the right order, you get a big performance enhancement. So our rule for that is put the question that is true most often first when using an or. Hope that makes sense. Tuck it away, and the next time you take another programming course in another language, it'll be discussed again, and you'll hear that it's called short-circuiting. Sounds bad. It's not. It's a good thing. Performance enhancement. So the truth tables describe how the logic works. Have I drawn a truth table already? Have I typed up in notes what a truth table looks like?
I think so.
Did you say yeah or no? Okay, here's what a truth table looks like. I'm not going to type it in again if I've done it before. Now, when writing logical or using electrical engineering, then the and is drawn as an up caret and or is drawn as a down caret. But just think of this as being the and truth table. Ignore everything else. The only time true is when both sides are true. Whether you represent it with zeros and ones to mean false and true, or whether you show trues or false. The only time is when both sides are true. If P and Q, if sick and tired, or if have money and hungry, that kind of thing. Or the only time it's false is when both sides are false, right? If I am sick or tired, I stay home. Well, I get to stay home if I'm both sick and tired. I get to stay home if I'm sick. I get to stay home if I'm tired. The only time I have to go to work is when neither are true. So those are the truth tables for and or. And then for not, it just flips it to the opposite. If you were writing logic, if you were taking a logic class or doing electrical engineering circuits, the not is represented by that tilde. And so, not P, well, if P was true, then not P is false. If P was false, then not P is true. So, right, if you say if A equals hungry, well, what's the opposite of that? We'd probably write if A not equals hungry. But you could write, excuse me, I may have said that wrong. Let me type it in. Better typing than speaking. If we come here and we have this expression, if A is equal to 1, but we want to write the opposite, we would probably do if A not equal to 1, right? Because we've been trained that that's a good way to write that something is not equal. But we could do if not A equals 1, like that. And you could leave off the parentheses, and it would work. Both do the same thing, right? Because if this is true, then the not would flip it, so it's false. So the only time that we would go into this block is when A is not equal to 1, in either case. If A not equal to 1, then print, it's not equal to 1. If not A equals 1, then print, not equal to 1. Do the same thing. Similarly, if we do this, what if we're trying to print if something is not freezing? Well, here's how we check to see if something is freezing. If T is less than 32. That's not freezing. Now we want to do the opposite. So we have to do if T greater than or equal to 32. But we could have worded it like this: if not t less than 32. Right? We could have just stuck not in front of the expression, and it means the opposite. And it's up to you which way you want to write it. Typically, the book recommendations, and I would kind of back this up, is to avoid using not, just because it ties your brain up into knots when your expression has too many knots. And my dumb example of that is if you tell somebody you ain't not going to the store, then people have no idea whether that means you're going to the store or not. Now that's because it's, weird vernacular, but ain't means am not, and so you're saying I am not going to the store, which means you are going to the store, right? Your brain has to do those flips if you're following the exact rules of grammar, and ain't actually has specific meaning. Anyways, if your expression is something like this: if not t less than 1 and not x is equal to 2 or y equals, right, your brain can't really figure out when that is going to happen, right, when that is going to trigger cheer. Oops, double equals, single equals. It'd be better to rewrite that expression so that it did not have the word not in it. So if t greater than or equal to 1 and x not equal to 2 or y is equal to 3. That's a lot clearer. It'd be clearer still if we used some parentheses to try to show what was going to happen first. And we could. We could put the parentheses here, and it means the same thing as it did before, but hopefully it's easier to read. Easier to read is better. In this case, the parentheses aren't necessary. Just like if you had, a is equal to, 2 times 3 plus 4. You don't have to put the parentheses around 2 times 3. It happens anyways. Inside its mind as it's interpreting it, as it's parsing the expression. But, maybe it helps make it easier to read if you have the parentheses around it. But they're not necessary. Okay, so rules of association. Which has higher precedence? Ands or ors? Well, if we went back to our truth table, this is an and, this is an or, and if we pretended that the falses were zeros and the trues were 1, 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1, that's the only time it's actually equal to 1. Now, or, it's like addition. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. What the heck? Well, it's because in Boolean math, there's only 2 states, 0 and non-zero. So 1 plus 1 equals 1. And if you take a logic course, that's probably how it will be expressed sometimes. So if you had this expression logically, and that's not a big deal to us, but if you had the expression x or y and z, then it would probably be written like this: x plus y z, right? Logically. Not in the computer, not in programming. We never leave the asterisks off. Or we could put the asterisk there, right? But anyways, so which happens first, the or the and? Well, what happens first, multiplication or addition? Which has a higher precedence, right? So, and is akin to logical multiplication. And or is akin to addition. So, and has higher precedence than or. Gets done first. And that's why I said in this case we could leave the parentheses off and it would still work. They'd just make it easier for the human brain to work. But if you really wanted this to be grouped with this, you'd have to use parentheses there. Just like when you're doing math, if you want the addition to be done before it gets multiplied, better group it in parentheses. All right, in most programming languages, logical and is a binary operator. Now that doesn't usually mess people up, but or does. bor is a binary operator too, meaning it has to have two complete expressions on each side. So what does that mean? What if you wrote this? If you want to check to see if your answer is equal to a lowercase y or an uppercase y. That's bad syntax. That would be a syntax error. And it's kind of unfortunate because that looks great, right? That looks like a great way to write it, and it's wrong. Instead, you have to do if answer equals little y or answer equals big Y. This is correct. The thing on either side of the or, the expressions on either side, the clauses on either side of the or, both have to be their own logical expressions. Right, so this has to be an expression that can evaluate to a true or false. If answer is equal to y, well, yeah, that can be either true or false. Answer is equal to capital Y, that can be true or false. Now what about up here? Answer is equal to lowercase y, that could be true or false. But just the letter y by itself, could that be true or false? No, because you'd have to compare it to something. And the other thing that sometimes gets people is they wish, because they've been trained, they know the math real well, that they could do this, right, to prove that something is between 32 and 212 non-inclusive, right, excluding the endpoints. It's cool syntax. It's a shame that it doesn't work in the programming languages I've ever learned, but this is wrong. Instead, you have to do if 32 is less than x and x is less than 212. That's correct. So it's a common mistake to try to write the code like this, where you're not treating or as a binary operator. Both of the operands, both expressions on either side of it need to be Boolean expressions. So and or are binary operators, meaning the operands, I hate using that word because it's too fancy, the things on either side, clauses on either side, must be entire expressions. And this is an expression, and this is an example of that. In fact, we can copy and paste this. Oh, by the way, I use these two ampersands. I apologize for that because that's not true in this language. But it's a good idea for you to see it. That's how you write and in some languages. In our language, you just put that. I'm just going to do that as a by the way. I changed those ampersands to the word and just because that's not Python. But in a lot of programming languages, 2 ampersands, shift 7, mean and. And I guess that's because the C programming language and maybe the languages before that in 1970 tried to differentiate so that only keywords and variables would have letters in them, and everything else would not have letters in them, so operators, of which and or. Because in those languages, I mean, you could write a language where, I'm not going to go down a rabbit hole, bad one. And expressions should not be trivial. A trivial expression is just one that's always true. Like this. If x is greater than 0 or x less than or equal to 0. Is that ever false? Well, as long as x is a number, no. Now that's kind of an obvious one, but there could be times when it's more subtle and yet winds up being always true. Or if you wrote something that was never true. If x greater than 0 and x is less than or equal to 0, is that possible? Could something always be greater than 0 and less than 0? No. So that's another trivial expression, except it's falsely trivial, which doesn't sound trivial to me. This is always false, so it's bad news. It would never trigger the code inside the if. If you took a logic course in a four-year college or something, and maybe they do this in discrete math, I don't know, but when you learn how to simplify lengthy, complex logical expressions, and once you simplify them, you may realize that large chunks of them are trivial, and you could simplify your expression by knowing that. So, or logic. One or the other has to be true. Are you free for dinners Friday or Saturday? Now, if we were to write this in computerese, we'd say, are you free for dinner Friday? Or is your free day Friday or your free day Saturday? Right, that means the same thing. In that case, let's go out. So you can ask either question first. Both produce the same output, but they vary widely in the number of comparisons. We've already talked about that. You want to put the first item, the first clause, the one on the left-hand side of the or, the one that's true most often, so it can skip evaluating the one that's least often. Eliminate as many extra decisions as possible. So you need to make sure the Boolean expression is complete. Just like I've been talking about and, if something is equal to this or this, can't write it like that. That's why I don't like that, are you free Friday or Saturday, because that makes it look like you could write it like that. And that makes it look like you could say if x equals 1 or 2. And you can't. You got to write if x equals 1 or if x equals 2. Leave off that second if word there. Make sure they're not trivial, in other words, that they're not always true. And the not operator. If your age is less than 18, you can't vote. But if not age, 18, sorry, I said 17. If your age is less than 18, then you can't vote. But if not age less than 18, we can register, right? And again, writing the word not there makes it hard to understand. And what I would do is I would write it like this, right? To me, that's easier to say, to understand. If age is greater than or equal to 18, then you can vote. It's a so-called unary operator, unlike everything else, which has been binary operators. It only takes one thing, right? If not x, only takes x. So opposites. The opposite of equal is not equal. The opposite of less than is greater than or equal. And the opposite of greater than is less than or equal. And I already covered why that's the case. I'm not seeing a lot of nods, so.
I'm sorry. I was typing.
No problem. I'm going to mention it again anyways. So, it doesn't seem like the opposite of less than would be greater than or equal to. It seems like it would just be greater than, right? The equal seems kind of weird in order to force it to be an opposite. But that is the case. Like if you do if x is less than 0, then print cold. But then if you wanted to write the opposite, if x is greater than or equal to x is greater than 0, print hot. Well, what if it was equal to 0? What's it going to print? If x is equal to 0, it's not going to print a darn thing, right?
It's going to syntax out, right?
Well, there's syntax errors all through this. I'm leaving off colons and stuff like that. But if x is exactly equal to 0, it's neither going to print hot nor cold. And if we wanted it to always print hot, if it wasn't cold, then we would need to make that. Now really, we'd probably just use an else, right? But you've got to remember that if you're reversing it, if you did this, if not x is less than 0, the way to reword that is to say if x is greater than or equal to 0. Those mean the same thing. And checking within a range. You use and to see if something is within a range. You use or to see if something is out of range. We want to see if somebody made a B. If x is greater than or equal to 80 and x is less than 90, they made a B. So, to check within a range, now what if we want to see if something is out of range? Now this supposed score cannot be increased beyond 100 and it cannot go below 0. So if x is less than 0 or x is greater than 100, print error. So to check outside of a range, we use or. And when you're doing this, you better decide whether your range is inclusive or exclusive, right? And for an A, it's all the way from 80 to 90 to 89.99999, right? So the 80 is inclusive. That's why we put an equal there. And the 90 is exclusive, which is why we didn't put an equal there. You'd be really annoyed if you earned the 90 and I told you it was a B. Did you understand the grading scale? So instead, we make it less than 90. So if you got your 90, it counts as an A. But if you got less than 90, it counts as a B. Same here. Our limits are not inclusive when written like this, right? Because if I made a 0, I'm not going to print error, and if I made a 100, I'm not going to print error. It has to be between those two values inclusive. So, just have to think it through carefully. Am I going to use less than, or am I going to use less than or equal? So, using range checks, you want to make sure you don't have what are known as dead or unreachable paths. For one thing, don't check for values that can never occur. And that kind of replies knowing the prior knowledge of the data. Never ask a question if there's only one possible outcome. And avoid testing the same range limit multiple times. Well, what does that mean? You could write your grade program like this. If x is less than 0 or x is greater than 100, print error. If x is less than or equal to 100 and x is greater than or equal to 90, print A. If x is less than 90 and x is greater than or equal to 80, print B. This is going somewhere. I'm not just typing this for funsies. This is way too complicated here. We could simplify that an awful lot. Why is simple better? Because we may have made a mistake. We may have left off the equal sign when it needed to be there. Or we may have put an equal sign here when there had better not be one. It would be better to rewrite this like this. I'm going to take all of this stuff and just copy and paste it and make a change to make it better code. So I'm leaving that the same. That's okay with me. But I'm going to take this part out. X less than or equal to 100. I'm going to delete that. And I'm going to remove the if x less than 90 and part. Okay, those mean the same thing as the prior code. But it's a lot fewer checks to achieve the same goal. And logically, we could, work through it. I could give y'all numbers and we could work through, each way. Maybe you can see that those give you the same results. So if you're checking to see if something is within a series of ranges, you don't need to word it like this. That's too complicated. You're checking the same range more than once. You're checking the 100 more than once. You're checking the 90 more than once. And if we kept going down, we'd be checking the 80 more than once. We essentially want to make the check for 90 only one time, and the check for 80 only one time, and the check for 100 only one time. And this is mentioning that if you're going to use and has higher precedence. So if you see this expression, if score 1 is greater than or equal to minimum score, and score 2 is greater than minimum score, and score 3 is greater than minimum score, well, that's dumb. That doesn't even have any ors. It's like doing all multiplication. You don't care about the precedence. And operators are evaluated first, just like multiplication is evaluated first. All right, I think we have enough time to implement the classic guessing game. Classic guessing game is when pick a number between 1 and 100. And if they get it right, we say so. The game ends. If they don't, we tell them. And they have to guess again. So, if you haven't been taking notes now, if you haven't been taking notes, why not go ahead and start so that we can actually write a program? This is Lecture P, I do believe. So, we're going to declare a variable called secret. This is our secret number. And I'm just going to pick one, right? We really want it to be random, but we can prove this, just by hard coding a number. And then later on, adding the code to make it random. That'll make it easier to test, right? Okay. So what we're going to do is we're going to set our guess equal to an invalid value. And what do I mean by that? I want it to enter the loop. This is kind of the priming read that we've talked about before. So if guess is equal to -1, that's an impossible value. That's nothing that we're never going to see. In a way, that's kind of our terminator condition. Nah, I won't say that. Okay, anyways. And then while guess not equal to -1, right, then start playing our game. That way we make sure we're getting into the while loop. Now we're going to ask them for their guess. Print, parentheses, quote, what is your guess? End quote. End question mark, end quote. Yeah, question mark, end quote, end parentheses. Now let's get to guess. guess equals input, parentheses, quote, greater than sign, just to let them know where to type, end quote, in parentheses. And yes, we could do all this in one line. And then guess equals float guess. Turned it into a number to play with. Now we're going to check to see if they got it right. If guess equals secret, if they got the secret number, we're going to print congrats. You know what? I don't like using this while guess is equal to -1. I'm sorry. I'm going to delete these two lines and rewrite them. See that guess equals -1 and while guess is not equal to -1? We're going to change that to correct equals capital F false. Has to be a capital F, has to be orange. And then while not correct, colon. Or you could rewrite that as while correct equals false. Whichever way your brain likes to see these things. If you don't like to see the word not, then you could do that. Okay. I like that better than kind of jury rigging to use our guess variable for two different purposes. So if we got the secret number, then yay, correct is equal to true. Then we may as well print a message. You got it! Exclamation mark. End quote. End parentheses. Else they didn't get it right, and we're going to tell them to guess again. So back tab, else colon, print, sorry, guess again, end quote, in parentheses. I'm just going to put a few comments here. And if that was back tabbed once, and end while, that was back tabbed twice, just because that helps my brain keep track of where I am. All right, now we've got our guessing game, and if I don't have any syntax errors, it'll work. Now this is kind of lame. We can make it a lot better, make it a lot more fun. But it should illustrate. All right, what's your guess? 50. Sorry. 70. Sorry. Now I've forgotten our secret number. I mean, I wrote it and I've already forgotten it. 60. Sorry, guess. And what would make the game more fun? Pardon me?
The secret number, you mean you set it to the value 75.
Okay, so I'm going to type in 75 just to prove that it works. Okay, you got it. All right. That is something I severely don't like about the game as implemented. If you were playing this with somebody, they'd get real tired of just having to guess numbers, right? What information could we give them that would make it more pleasurable to play, that would give them more information?
You can give them hints.
Yeah, we need to give them hints. When I typed in 50, what should it have said if it wasn't right?
Low.
Right, guess higher,
Guess higher,
right?
yeah.
Your guess is too low, that kind of thing. So we can change our logic to handle that. To do that, I'm going to delete these lines, or maybe I'll just put it here, inside the else. Nothing wrong with doing it inside there. So inside the else, on the same tab level, same indentation level as that, let's check. If guess was less than the secret number, we're going to print too low. If guess less than secret, print parentheses, guess was too low. End quote, end parentheses. Else, the guess was too high. Now I'm going to go ahead and put a redundant check here, just in case I wind up cutting and pasting. A simple else would be good enough at this point. In that case, why don't we leave it off? It's less typing. Else colon, print, guess was too high. Now why am I saying that we didn't have to do a secondary check? Because we only get into this code if the guess was not equal to the secret. So we know at this point that there's only two other possibilities, that it's too low or too high. Now, I'm not really totally satisfied with the way we did this because we could have worded it without indented ifs, but it's okay. How could we have reworded this? How could we revise the logic a little bit so we did not have to indent, so we did not have to nest a second if check? We still need the check, but we could have used elif, right?
Yes, sir.
Elif guess less than secret, print guess was too low, else print guess was too high. And I think we ought to go ahead and do that. It will not take much revision. I'm just going to delete this line entirely so that I can use elif. In fact, let's change the else first. So I'm changing this line right there. That line's getting changed. That's going to be elif guess less than secret colon. See, I changed that line, which lets me delete those two lines. And then lastly, I better back tab the else colon. All right, I think that logic is clear. If we had to flowchart that, that'd be a lot clearer than having to use a nested if statement. Let me test this, and now that I've been hacking, cutting, and pasting and stuff like that, I may have messed it up for y'all. Let's find out. So, my number's 50. Guess was too low. My number's 90. Guess was too high. I can zero in on it, right? 70. Too low. 75. And that bet was just right for Goldilocks. We got to it. Alrighty. Now that's known as a binary search algorithm. We picked a spot right in the middle, right? You know, we could have just started at 0 and kept going up, right? Is it 0? No. Is it 1? No. Is it 2? Nope. Your partner in the game will get really annoyed with you for doing it that way, right? Because it could conceivably take 100 different tries in order to find it. On the average, it would take 50 tries in order to find it. And that's way lame. You'd be playing that game all day. But if you guess the middle, 50, no, go higher. Or go lower. All right, I'm going to go to 25. See, each time you're cutting the list in half. No, go higher. Well, what's between 25 and 50? Maybe 37 or 38. Guess that, right? And you can zero in on it really quickly. And if I recall doing a binary search algorithm where we keep cutting the list in half each time, you could always get this number within 6 checks or less. I could be slightly off, maybe it's 7. But that's a lot better than an average of 50 or a maximum of 100. And if we did it like that, then even if you increased it to 1,000, it still only takes something like 10 or 11 checks to find it at a max. That's kind of hard to believe, but it's true. Okay, so if you have 100 values to choose from and they are sorted sequentially, like our numbers 1 to 100, at max it's going to take 6.64 times in order to find it. Now that 64 is kind of ridiculous. So let's say maximum of 7 guesses. And we could prove that if we follow the algorithm perfectly. 50, 25, 37, and then a value between those, zeroing in on it. What if it was 1,000? It would take at most 10 checks. Well, that's only 3 more. Now I don't even see how that's possible for it to, but we could try it out. We could make a random number, that was between 1 and 1,000, and we should be able to guess it within 10 guesses. And sometimes even faster. What if it was 10,000? No more than 13 or 14 checks should always get our answer. Whereas if you did what's known as a linear search, you start at 1 and you just keep going. If you had 10,000 numbers to search that way, on average it would be 5,000 doing a linear search. Doing a binary search, the maximum would be 13 or 14. Way better performance. So a takeaway on that is if you can find a way to keep your data sorted, you could do accesses far more quickly into it, which is why databases have index. If you ever do SQL programming, SQL programming, then they have indexes which keep the data preserved in a sense so that if you say, I want all records with first name of Jeff and last name of Thompson, it'll spit them out really fast. All right, what else could we do to make this more fun? Well, for one thing, we could actually make it a random number, right? What else could we do? Let's make sure that everybody who wants it to work. What would make our game more fun? I mean, not that this is the funnest thing in the world. The funnest thing in the world would be like if there were some stakes involved. If you got it within 5 turns, I'd give you a buck, right? Or within 7, trying to prove that you could do the algorithm perfectly. A counter telling us how many guesses we have made would be more fun. And we could even implement some kind of check. If the counter gets too large, we say, sorry, give up. Go play tic-tac-toe, right? So we need a counter, in my mind. Another thing that might make it more fun, which I don't think we're going to implement, but we could, is what if we told them that they were close? Like if they were within 5, we told them it was close, right? Because if they guessed 49 and our first guess was 50, well, if they didn't get it right, they got to go all the way back down to 25. Then they got to pick 37. Then they got to pick 42. Then they got to pick 4. You know, that would max out the number of guesses. It would take them like 7 guesses, right, to get to 49 just because it's at that equal. It'd be nicer if we said, no, but you're real close. You're a little too high. And then they guess 49. And we could do that. We could do that. We could add some if clauses here, right? If guess is less than secret, but greater than secret, plus 5. My brain's not working well enough in order to figure out how to implement that. We ought to take the difference between the two and the absolute value, and if the absolute value was 5 or less, then tell them they were really close. But I don't see how to do that easily, so I'm not going to do that. But a counter is pretty easy. So on a while loop, you always have to initialize your variable before you can check it, right? I could not say while not correct before I had a variable to check, right? If that line was missing, and don't delete this, then how would it check to see if we were correct? All right. Similarly, if we're going to use a variable inside the loop, if we're going to say, you know, counter plus equals 1, that counter had better been initialized to begin with. So up here, above count, correct equals false, I'm going to say counter is equal to 0. Now, I don't like the fact that both of those start with C and they look very similar. I could call it guesses or turns. Let's call it turns. That's really blatantly easier to see. And then, so this is our new statement. And then here, let's add 1 to the number of turns. Turns equals turn plus 1, or turns plus equals 1. And then we may as well print that out, right? Print it is turn, end quote, comma, turn. Or we could have just put turn equals. Let's do that, it's shorter.
It's called turn with an S.
Oh, yeah, you're right. I'd rather it be singular. Sorry to waffle on y'all. But I'm going to make that turn. Just because you say, like, this is, you know, which inning? I'm on inning 3. You don't say, I'm on innings 3. So, turn plus equals 1. I just added that line. And for my print statement, turn is equal to, turn equals, end quote, turn in parentheses. And so I just added those 3 statements. And I got an error. And I closed my file. Recent files. Run it again to see my error message. It's complaining that I have a triple quote that's not closed. Oh, when I was talking about the test question. If you didn't type that, great. I did, so I had to close my triple quote. All right, now I think it's going to work. Turn number 1. What is your guess? 50. Too low. What is your guess? 25. Still too low. Well, I should have gone higher. 75. Bingo, you got it. I'm bored with the fact that the number is the same each time. So, let's make it so that we can pick a random number. So above that secret equals 75, we need to import a library called random. Just like earlier in the year we were doing import turtle. Here we're going to do import random. That's our new line. And instead of secret is equal to 75, we want to do secret is equal to random dot, and it's going to be a little bit weird, R-A-N-D-I-N-T, random int, rand int, kind of abbreviated. And we want to start with 100, and we want to end, 1 comma 100. We want our number to be between 1 and 100. And that was a new one. All right, now we don't know what the random number is. Now it's a game. So I'm going to see how many turns it gets me to get it right if I try to implement the binary search algorithm exactly. 50, it was too high. 25, still too high. Well, what's halfway between 1 and 25? Maybe 12. Too low. All right, halfway between 12 and 25. Oh gosh, that's like 13, 18. I don't know. I'm not doing it perfectly. And that was too high, so halfway between 18 and 12 is 15. You got it, right? So it took me 5 turns to get it.
What was that? Can you go back to the code?
Yep. This is the stuff that we changed. We added those 2 statements. Gonna do it again real fast so that you're capable of having it. All right, so we had some set statements up at the top, right? Blah, 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 whatever. I don't know how many set statements we had, what they were doing, so I'm going to put those in there. And then we had a while. While correct equals false. And as long as correct was equal false, we asked some input. We did something. I don't know what. And then we had some if statements, at least one. Now I wish I'd left it as the indented and nested. This is making it too easy if I give you all this. And then you're going to do something if that's true, right? And you're going to come back, and either way, if it was true or not, you're going to have your elif. And then if that's true, you're going to go and do something else, right? I'm not liking the way that looks. I'm going to move that arrow up there because we always actually had them join at a circle, right? And if that was true, then we're going to do something, whatever. And then finally, we had an else down here at the clause at the end, right? Else. We did something else. We told them something else. Something like that. Now, this is absolutely not complete. And after they joined together, then we had to loop back up to the decision again. Like, something like that, or we could draw the line going all the way over. And then we were done, so we just put a stop at the end. And so we should have had a start at the very beginning. All right, kind of ugly, but that's how you're going to do it. I should post a picture of this in the notes so that or in the homework assignment so that you have a good shot at it. Now, it's completely wrong, right? I don't have lines between everything, and, we had some print statements, and I'm missing a place where we incremented a counter and stuff like that. But that's the basic idea. Here's the while. I'm going to change the word decision to while. While whatever. You'd fix that. If you don't like drawing it like that where the line comes back to the diamond, the book shows the line coming back. Well, that's wrong. The book shows the line coming back and going above the diamond. You like doing it like that? That's totally okay. To me, it's easier just to draw it going back to the diamond. All right. So I gave you 3/4 of the flow chart here. It's hard to get that one wrong. The thing that I'm seeing most wrong in the flow charts is people putting print statements inside square blocks rather than tilted blocks. It's like everybody got the idea that input needed to be in a tilted rectangle, but not that output or print needed to be in a tilted rectangle. So since these are actually print too high or print too low or print just right, that kind of thing, you better use tilted rectangles where appropriate. So that'll be the homework.
You're just doing a flow chart for this program we wrote right here.
Exactly. Flowchart our guessing game program. Now, if we were going to take a minute more to improve the program, I would make it so that the number of guesses, had a limit. They could not guess more than 8. Counting it down, guess, sorry, you only have 2 more guesses left, something like that. But then that gets us to something to flowchart that is really hard to flowchart, which is some kind of break statement or something like that. And I don't want to do that. I don't want to add anything to our code that's difficult to flowchart. All right, that homework makes sense, guys? Using the example that you will see in the homework document when I copy and paste it or whatever, it'll be not too hard, but don't follow it too closely because I left out a lot of steps and I put the wrong shapes for some of the steps. Remember that if we do a print, input, float, those three things can just be replaced by one block that says input X or input guess or whatever. You don't have to do those 3 things, all 3 things in the flow chart. Just make it simple on yourself. Just draw one block for input X rather than print message, input it, and convert it. All right, let's make a drop box for this.